Hello everyone, just want to take a little time to do a quick tutorial applying what you learned in the Predicting the Products lecture. This is combustion reactions, and when we take a look, I just want us to remember how we identify that this is combustion using our flow chart. When we take a look at our reactants, we have a hydrocarbon plus oxygen. We don't have two elements over here. So when we take a look at this is a compound, so it's not synthesis. When we take a look at decomposition, there's two reactants, so it can't be decomp. We have a compound and a compound here, but a compound and an element here, so it can't be double replacement. So that really only leaves combustion or single replacement. We might consider that it is single replacement because you have an element and a compound, but notice that the compound has to be ionic. Here, this compound doesn't have a clear ion to switch out. And because we have that C and H within the compound mixing specifically with oxygen, this one is combustion. Now, based on our chart, it says our products are always CO2 and water. So that makes this easy to predict the products, but the challenge is in the balancing. So I'm going to write in my CO2 plus water. Okay, and I'm going to make my chart. Now remember, with combustion reactions, these have a very specific strategy. Whoops, let's get rid of that extra H. Where if I do the C's first and then the H's and then balance the O's, I often can balance it in one go. So over here, I have 7 C's. Over here, I have 1. Over here, I have 6 H's. On the right side, I have 2. And over here, I have 4 oxygen. Notice this one has oxygen in 2 places, so it's really important to take note of. So I have 4 oxygen over here, and I have 3 over here. So now I can go ahead and get started with my balancing. So I'm going to start with the C's. I'm going to make that a 7. That changes C to 7, but also changes my oxygen. 7 times 2 is 14, plus 1 is 15. I'm going to then make my H's match. Here I have a 3. So when I do 6 hydrogen, I have also changed my oxygen. So now I have 14 plus 3 is 17 on the right. And I have an O situation. Notice, because of the way the oxygens exist on the left, I need to have an even number on the right. So we're going to use that doubling trick. I'm going to make this a 6. We're going to make this a 14. This will become a 2. So if I take a look here, 2 times 7 gives me 14 of those, which matches the 14 on this side. That's a 4, not a 9. I have 2 times 6 is 12 here. 6 times 2 is 12 here. Okay. Now I got to figure out my situation with the oxygen. 14 times 2 is 28, plus 6 is 34. Now over here, I need to come up with the coefficient to make the oxygens balance, but I'm going to have to take off the oxygens that are right here. 2 times 2 is 4. So I'm going to have to do 34 minus 4 equals 30. So that's what this coefficient needs to get us to. Well, 30 divided by 15 or divided by 2 gives me 15. So when I add the 4 oxygen from here to the 15 times 2 of 30 here, I get my total of 34. So the final answer would be 2 of the C7H6O2 plus 15 oxygen yields 14 carbon dioxide plus 6 water.